Okay, so what we're going to look at here is factoring, all the different types of factoring we saw this year. We've been doing it throughout the year, so this should be familiar. So this should hopefully be a quick review, and we'll cover several problems. Now, after I get through all the factoring that I'm going to get through, at the end of this, you'll find a couple of problems that are a little bit more challenging based on questions that were on released SOLs. So you can stay tuned for that or skip ahead if that's what you're looking for. All right, so let's start off by factoring some binomials. Now, one thing I need to stress to you, when we are factoring, we always have to remember that our first step is to factor the greatest common factor. That is always going to be your first step, to take out the GCF. Now, for most of these, I didn't bother to put in a greatest common factor because we've emphasized it so much throughout the year. I want to just focus on the main topics of factoring. However, some of them, it is something that you need to worry about. So this first one right here, 5w squared minus 180z squared. Well, right off the bat, I see that 5 and 180 have a common factor of 5. So if I take out that 5, I will be left with w squared minus 36z squared. Now, I recognize this as a difference of squares. And a difference of squares, this is a very simple factoring pattern. What I need to figure out is what numbers do I square to get w squared and 36z squared. And I'm going to take those, once I will subtract them and once I will add them. So when I'm factoring this, I'm going to go ahead and bring down my 5 because that's a factor now. I know that's a factor of the original polynomial I started with. So w squared minus 36z squared. Well, w squared is w squared. And 36z squared is 6z squared. So what I'm going to do is take that and I will subtract them once and I will add them once. Now, of course, the order you put them in doesn't matter because we know that multiplication is commutative. So whether I wrote w minus 6z first or w plus 6z first, it's the same product either way. Now let's take a look at this one over here on the right. So the most obvious difference between these two problems that I've just seen, here I had squares and here I do not have squares. I have m to the third and n to the third. Well, these numbers are cubes. What I'm looking at here is a difference, because I'm subtracting, of cubes. Each number that I see in front of me is a cube. All right? So the question is, what are these cubes of? Well, 8m cubed is 2m cubed, and 343n cubed is 7n cubed. So these will be my A and my B when I talk about the pattern I know for the sum or difference of cubes. The pattern for the sum or difference of cubes is I do A, then B, A squared, A times B, B squared. And what I want to do is you got to have this down because you will have to use this. It's something that at the first chance you get to write on your scratch paper or write on your formula sheet, this is probably something that's worth writing down. So I have all that, but I need to fill in the signs in the middle. Well, I remember I fill in the signs with SOAP. I want the same sign, the opposite sign, and the last one should always be plus. So right here, the same sign is subtraction, opposite will be plus, and then always plus. I'm going to fill this in using 2m and 7n. First up, I'll have 2m minus 7n. Be careful here. When I say a squared, that means 2m is being squared. 2m will be multiplied by itself, which means I will get 4m squared. Always remember that when you multiply this out, what does it have to be? 8m cubed minus 343n cubed. So right here is where you're going to get 8m cubed from. 2m times 4m squared. A times b, if I multiply 2m by 7n, I will get 14mn. And plus b squared. Well, I'm squaring 7n, which means I will get 49n squared. And then it's factored. That's how you factor a sum or difference of cubes. Let's go ahead and keep moving. We'll see a couple more binomials before we move on to any trinomials. All right. Here I have 81p to the fourth minus 16. First thing I do is I look for a greatest common factor. They don't have any variables in common, and 81 and 16 don't have any common factors apart from 1. So I don't have to worry about that. Now I've got p to the fourth, I've got 81, I've got 16. I recognize that all of those are squares. So what I'm looking at here is a difference of squares. What are these squares of? What do I square to get 81p to the fourth? Well, I square 9p squared. 9p squared, if I square that, is what will give me 81p to the fourth. What do I square for 16? To get 16, I need to square 4. So I'm going to use these two. Again, I will subtract them once, and I will add them once. Now we saw this come up a few times throughout the year. Be careful here. I'm not actually done. Because if you look at this first factor right here, I recognize that, hey, 9p squared and 4 are all squares. And what's more, this is still a difference of squares. Right here, this is what we call a sum of squares. A sum of squares does not factor, it's prime. So you can leave that alone. This one right here, though, I will have to factor that. 9p squared. Well, 9p squared is 3p squared. 4 is 2 squared. So how do I factor this? I subtract them once, and I add them once. So I can now see from this one binomial I produced 3 different binomial factors. 3p minus 2, 3p plus 2, and 9p squared plus 4. Now at that point, that's as much as I can factor it. And I can move on to my next example. Right here, when I look at x to the 12th plus y cubed, well, I see x to the 12th. Again, I always need to be asking myself, am I looking at squares or cubes? 12 is a little bit tricky because technically it is both a square and a cube. Since 12 is even, I know that this is a square. Since it's divisible by 3, that means it is also a cube. But the fact that I have y cubed here means that I definitely need to be looking at cubes. The other giveaway is that there's a sum right here. This is the sum of cubes. If these were both squares, I know the sum of squares is prime. I'll make that note right there. So, the question is, what are these cubes of? X to the 12th is the cube of what power of x? Well, it'll be x to the 4th cubed. Y cubed is, of course, y cubed. But again, I have to stress, this is x to the 4th cubed. The actual math here, remember in algebra you learned to multiply the exponents, but the actual idea is if I say x to the 4th cubed, what that means is x to the 4th, x to the 4th, x to the 4th. Which means I would have 4 x's, 4 more x's, 4 more x's for a total of 12 x's being multiplied. Anyway, again, I'm going to use my pattern. So I'm going to write my pattern over again so that I can just fill stuff in. AB, a squared, AB, excuse me, I wrote a squared. I should have written b squared right there. I fixed it. And then I'm going to fill this in using SOAP. I want the same sign, the opposite sign, and always plus for the last one. All right? So here, what will that be? I will have x to the 4th plus y. A squared, if I do x to the 4th squared, x to the 4th times x to the 4th is x to the 8th. Minus a times b, if I do x to the 4th times y, I just get that. That can't be simplified in any interesting way. And if I square y, I get y squared. Now at that point, I am done factoring this. That's how this factors x to the 4th plus y times x to the 8th minus x to the 4th y plus y squared. This one binomial produced 2 different factors. Let's go ahead and move on to trinomials. Now trinomials we spent a lot of time on this year, and we did them a lot with rational expressions. When we did them with rational expressions, we discovered that this whole long process that we've been doing all year, what we discussed was that, well, if the leading coefficient is 1, as it is right here, I actually don't need to do that whole process. I can go through the same steps I would normally. Look for factors of negative 24, things that multiply to negative 24 that add up to negative 10. Excuse me, let me move this down a little bit. Well, I'll make a little table right here, even though 24 is a pretty easy one. 24 is 1 and 24, it's 2 and 12, it's 3 and 8, and it is 4 and 6. Be careful here with these numbers. It has to multiply to negative 24. The fact that it multiplies to negative 24 means I want a positive and a negative number. So don't be fooled by thinking, oh, I can get negative 10 if I do negative 4 and negative 6, because I want one positive and one negative. If I'm using one positive and one negative, what I have to do here is use 2 and 12. If I do a negative 12 and a positive 2, that will give me a sum of negative 10 and a product of negative 24. I can't stress that enough. You have to be extremely careful with your signs, and you have to watch out for problems like this, where it appears that there are two ways to get one particular sum. But again, you have to pay attention to, do I have two negatives or two positives or anything else different? Let's take a look over here. I've got negative 8y squared plus 40y minus 48. All right, well, first off, I've got a leading negative, so I know I need to factor that out. What's more, I have 8, which divides 8 and 40 and 48. So my greatest common factor here is negative 8. Always need to remember to look for the greatest common factor. If I don't, it's going to make my life a lot harder, and I generally won't get the right answer. Take that out, I get negative 5y. Down here, if I take out a negative 8, I will get plus 6. So again, this has a leading coefficient of 1, which means it's just y and y. And the question becomes, okay, what multiplies to positive 6 and adds to negative 5? Again, be careful here. Positive 6 is 1 times 6, or 2 times 3, or negative 1 times negative 6, or negative 2 times negative 3. If it multiplies to positive 6, I need either 2 positives or 2 negatives, which means what I will need here is 2 negatives. I can't make this work with 6 and 1. I have to make it work with 2 and 3. So this is my factorization. Negative 8 times y minus 2 times y minus 3. Again, make sure these numbers actually multiply as they are supposed to. Negative 2 times negative 3 is positive 6, and add up as they're supposed to. Negative 2 plus negative 3 is negative 5. So at that point, I can move on because I have factored this. Let's take a look at a couple more trinomials, and then we'll keep going with this. 7d squared plus 5d minus 48. Now, when I am doing this, I have to work at this a little bit, because the leading coefficient, first off, is not 1. So I'm going to have to launch into my whole process of factoring. I know I'll bring those down, and I know in here I've got to multiply 7 and negative 48. Well, 7 times negative 48 is negative 336. Now, most of these problems we see, dealing with the variables is trivial. If I have two things that add up to 5d, that needs to be d and d. d times d is d squared, so all of that works out well. But what's really tricky here is finding numbers that multiply to 336 and add up to 5. Now, I've shown you this in previous examples. What I'm going to do here is just cheat. Rather than going through and finding all these factors manually, I'm going to do 336 divided by x. I'm going to put this into the calculator, and then I'm going to go to the table. My table is somewhere else. I'm going to go back up to 1 to show you how this will start. There I see an error. So what this is showing me is the table of factors for 336. 1 times 336 is 336. 2 times 168 is 336. 3 times 112 is 336. And so on. Down here, where this is a decimal, that means that 5 is not a factor of 336. So what I need are two numbers that multiply to negative 336 while adding to positive 5. Again, if it multiplies to a negative and adds to a positive, I will want one positive number and one negative number. So how can I make this work? Well, let's scroll through. 4 and 84, for example, would give me 80 if I did one positive and one negative. 6 and 56 could give me 50. 7 and 48, 41. 8 and 42 would give me 34. That's not good. Can't use that. Can't use that. 12 and 28 would give me 16. I'm getting closer. 14 and 24 would give me 10. 16 and 21. Well, 16 and 21 would clearly give me a positive 5. I will need a plus 21 and a minus 6. So now I'm going to factor this. I've picked my factors. They multiply correctly. They add up correctly. Excuse me, I wrote down 6. Please fix that. It should be 16. I'm very thankful I caught that mistake and didn't have to remake this. Let's group these. Here I have 7d times d plus 3. Here I know I'm going to take out the leading negative, and 16 goes into 48. 16 goes into 48 3 times. So I know this worked out well because I got d plus 3 in both places. So what are my factors then? Well, I know one of them is d plus 3, and the other one is these leftovers, which are outside, 7d minus 16. And then I'm done. I have factored 7d squared plus 5d minus 48. Now, if this problem had asked me to instead solve a quadratic by factoring, I would then have to take these, set them equal to 0, and solve. But I was simply asked to factor here. Now let's move over to this problem, 20n squared plus 17n plus 3. The leading coefficient is 1, so I'll have to do my whole process here. I need factors of 60n squared, which add up to positive 17n. So again, I can make that work with n and n, that's not a problem. But the question is, well, what two factors of 60 is that? Well, 60 is 1 and 60, it's 2 and 30, it's 3 and 20, it's 4 and 15, it's 5 and 12, and it's 6 and 10. If they multiply to positive 60, they'll have to both be the same sign. Positive 60, positive 17 means these are all both going to be positive numbers. So, how do I get 17? Well, with 5 and 12. And then I group. 5n is the GCF, leaving us with 4n plus 1. Here, 3 will be the GCF, leaving us with 4n plus 1. And then, again, I got the same thing, so I know I've done this well. My factors are 4n plus 1 and 5n plus 3. And I factored it. Now there are two more basic factoring problems I want to deal with, one trinomial and one polynomial with 4 terms, before I look at these more interesting problems that I said I would show you from the SOL. Alright, we've seen ones like this before, and we know that they can be somewhat tricky. I need to find what factors these are. Well, how is this different than what we previously looked at? I start off with x squared, and that's normal. But then my middle term is xy, and my final term is y squared. So I'm going to have something interesting with my variables going on here. Now, the greatest common factor here, sadly, again, is 1, so I get no help there. I'm going to multiply my first and last term and get 120 x squared y squared. So this is the first example we've done in this video where you actually have to think about, do these variables work out correctly? Well, if it has to add up to something with an xy, it needs to be xy and xy. xy times xy will give me x squared y squared, so the variables work out okay. The question is, what multiplies to 120 and adds up to negative 23? If it adds up to negative 23, I know I'll want two negatives. This will be 1 and 120, it will be 2 and 60, it will be 3 and 40, it will be 4 and 30, it will be 5 and 24, it will be 6 and 20, it will be 8 and 15, and lastly 10 and 12. Those are all the factors of 120. The question is, where does 23 come in? Well, right there. If I do a negative 8 and a negative 15, then I know that that will give me a product of positive 120 x squared y squared and a sum of negative 23 xy. All right, let's factor. Here the greatest common factor is 4x, which leaves us with 3x minus 2y. Down here, I see a leading negative. 15 and 10 have a 5 in common, and then looking at the variables, both of these have a y. So my greatest common factor for this second group is negative 5y. If I take that out, to get from negative 5y to negative 15xy means I'd need 3x. To get from negative 5y to positive 10y squared means I would need negative 2y. And again, I got the same thing. That means I'm doing a good job. I know I've done what I'm supposed to do if I get the same thing in those parentheses. Otherwise, it means I made a mistake. So watch out for that. Don't be afraid to go back and fix your mistakes, because otherwise you're just leaving points on the table. So at last, I've factored this polynomial. And this thing that looked quite ugly looks quite simple once I've factored it. But again, we have to be cognizant of how to do this, how to deal with the fact that it's not simply x squared x and a constant. All right, one more example. I don't know that you'll have to do this on your SOL, but again, it's worth seeing. Here I have a polynomial with 4 terms. So what I can do is just dive right in and separate it into 2 groups of 2. If I do that, 4x cubed and 24x squared. They have a 4 in common. X cubed and x squared means I need x squared, which will leave me with x plus 6. For the second pair, negative 9x minus 54. Well, I know that I take out a negative for the leading negative, and 9 goes into 9 and 54. So that will leave me with x, and again, since I'm taking out a negative, I'll get a plus 6. So I know I've done this well. Again, it's the same thing. I have x plus 6 times 4x squared minus 9. Okay. Am I done, though? Again, always check and make sure that you are actually done. Since this is 4x squared minus 9, that means that, again, this is a difference of squares. 4x squared is 2x squared, and 9 is 3 squared. So I can go ahead and factor this more and get 2x minus 3, 2x plus 3. Then, and only then, am I done. I went from this cubic polynomial up here to 3 trinomials. And you could always check by multiplying it back out. Since I know it was a cubic, this makes sense because x times 2x times 2x would give me 4x cubed. And I know at the very least I would have the correct leading term. So let's be aware of that. Now let's go ahead and look at these 2 problems that were from released SOL, which you have not seen. Here you're asked for the complete factorization of 18x to the 4th plus 12x cubed minus 6x. And I've shown you the 4 answer choices that were presented with this problem. Well, in order to factor, again, we must remind ourselves consistently that our first step is to take out the greatest common factor. So let's copy this down here, 18x to the 4th plus 12x cubed minus 6x. Once we discuss how to do this problem, we'll discuss why a couple of these answers at least don't actually make any sense. Well, 18, 12, and 6, I can take out a 6, which fits with all my answers. X to the 4th, x cubed, and x. Well, that means I can take out an x as my greatest common factor. That will leave me with 3x to the 3rd to get 18x to the 4th, plus 2x squared to get x cubed. What about if I'm factoring out from a negative 6x? Well, if I do 6x and I'm factoring out from negative 6x, that will leave me with minus 1. I need to remember that because I'm taking the greatest common factor from a trinomial, what I should get is that GCF times a trinomial. If I don't get a trinomial, I know this is wrong. Now I'll pause here for a second. I've already ruled out 2 of the answers. The GCF was not 6x cubed, so I know A is wrong. The GCF was 6x, but as I said, if I'm factoring a GCF from a trinomial, I need to be left with a trinomial. This is missing an entire term, so B does not make any sense. So I'm left with either C or D. All right, well, if I want to figure that out, what I need to do is ask myself, can I factor this polynomial right here? Can I factor 3x cubed plus 2x squared minus 1? Well, if I did this, I would need factors of negative 3x cubed that add up to 2x squared. Now let's think about this before we get too deep into this problem. If it has to add up to 2x squared, if it has to add to that and multiply to negative 3x cubed, that would mean I need x squared terms. They'd have to both be x squared in order to add to 2x squared. Well, what's the problem? If I multiply 2 terms with x squareds together, I don't get x cubed. X squared times x squared is x to the 4th, not x to the 3rd. Which means this cannot be factored because the variables don't work. So be aware of that. Don't just blindly charge through this. If you did blindly charge through this and not think about the variables, in all likelihood, you would end up with answer choice C. That's why it is there. What I've just shown is that these variables don't work, so this trinomial doesn't factor. So you see that this is actually answer choice D. And I can stop right there. Another quick comment on C. Well, I know that whatever my factorization is should multiply out to 18x to the fourth plus 12x cubed minus 6x. If I multiplied the leading terms from these three factors, 6x times 3x times x does not give me 18x to the fourth. It actually gives me 18x to the third. So this is off by a whole x. C is not a good answer because of that. D is the correct answer, the only correct answer. I have no means of factoring that trinomial. All right, last one. For which value of b is x squared plus bx minus 60 factorable over the set of integers? Okay, well, let's think about this. The most obvious thing perhaps to do for this problem is to just substitute b and check, can I actually factor this? So I would have x squared plus 61x minus 60 if I had answer choice A. And then if I tried to factor this, I'll show you the full steps. I would need factors of negative 60 that add up to 61. Well, the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, or 6 and 10. Now I see 61 right there if I do 1 and 60. But again, what's the problem? It has to multiply to negative 60. If it multiplies to negative 60, that means I want one negative and one positive. So 61 will not work. It will not make this factorable. So much for A. Now I could go ahead and try this as well with 23. Darn it, don't forget that x. Obviously, that's very important to put that x there. So, do I have factors of negative 60x squared that add up to 23? Well, where is 23 going to come from? I can see right there with 3 and 20, but again, I need one negative number and one positive number. 3 and 20, I would actually have to have either negative 3 and 20 or 3 and negative 20, which would give me 17 or negative 17. I guess that means there's no way to get 23 out of this either. All right, now I could keep doing this, and obviously that'll work. But what is this question really asking? Is there a better overall approach to this? Is there another way that I could do this? Well, the answer, of course, is yes. If I need one negative number and one positive number, I could use 1 and 60. If I were to use negative 1 plus 60, what would that give me? That would give me 59. If I were to use, instead, positive 1 and a negative 60, that would give me negative 59, which means I have possibilities of plus or minus 59 for the value of b. If I did 2 and 30, I could either do negative 2 plus 30, which gives me 28, or I could change the signs and get plus or minus 20, and get negative 28. If I did 3 and 20, negative 3 plus 20 would give me 17. If I changed the signs, I would get the negative version. And I can keep doing this. If I did 4 and 15, 4 and 15 would give me plus or minus 11. 5 and 12 would give me plus or minus 7. 6 and 10 would give me plus or minus 4. So, this is a list of 12 numbers. 59, negative 59, 28, negative 28, 17, negative 17, 11, and negative 11, 7 and negative 7, and 4 and negative 4. Any of those 12 numbers would make this polynomial factorable. Which one is among my list? Clearly, negative 7. Now this is an interesting problem, and it's worth knowing how to do because it's possible to figure it out. And if you can figure it out, why not know how to do it? All right. So I'm going to show you one more example like this, and we'll talk about how we can figure out the possible numbers. So I'm just going to write this one down right now. Let's say I have 3x squared plus bx plus 24. And I want to know, okay, what are the possible values of b to make this factorable? Same question. Okay. Well, here I have to think about this a little bit more. If I was factoring this, the first thing I would need to do, and again, I don't know what b is going to be, is multiply 3 and 24 and get 72x squared. So what I need to know is, what are the factors of 72? Make a little table right here. 72 is 1 and 72. It is 2 and 36. It's 3 and 24, of course, because that's where it just came from. It is 4 and 18. It is 6 and 12. And it is, of course, 8 and 9. Now, if it has to multiply to positive 72, that's either 2 positives or 2 negatives, which means I could have 1 and 72 or negative 1 and negative 72. I could have 2 and 36 or negative 2 and negative 36. Those would give me positive or negative 38. For 3 and 24, I would get either 27 or negative 27. For 4 and 18, 22. For 6 and 12, 18. And for 8 and 9, 17. So in this similar question, to make this polynomial factorable, what I would need is for b to be one of these, and again, coincidentally, it's 12 numbers, one of these 12 numbers, positive or negative 73, positive or negative 38, etc. Any of those would make this factorable. Some of them would make it so there's a GCF, of course, because 27 and 18 are both divisible by 3. Others would make it so there's not a GCF, and I'd have to actually factor this the whole big long way. But again, it's food for thought, and it's understandable. You put in so much work, you know how to factor. You know how to think about math is the goal. Again, I hope this has been helpful. Good luck.